Hello, my name is Lubo, and in this video I'm going to present you the Vieta's formulas for polynomial equations, how do they work, and the proof of them. So let's get started. First of all, let's review what are the actual formulas. So in every quadratic equation, which states as you can see, a times x to the power of 2 plus b times x plus c equals 0. We have two roots, and for those two roots we have two formulas for their sum and their product, and their sum is the second coefficient over the first one, and we have to put a negative sign in front of that, and for their product, when we multiply them, we have to take the third coefficient and put it over the first one. So alpha and beta, which are the two roots, their sum is minus b over a, and their product is c over a. To start with the proof part of this video, we have to copy the equation above. And when we finish it, we have to write such a thing, which is another formula actually, which is the first coefficient of the quadratic equation, which is a, times minus every root of the equation when we subtract it from x. So x minus alpha, which is the first root, times x minus beta, which is the second one. And what we have to do now is just copy the first row, but unveil the brackets. But we will save the a for now. So when we unveil the brackets, we will get x to the power of 2 minus beta times x minus alpha times x. I should have write them in other way, but it doesn't really matter, plus alpha times beta. Now we copy the second row. I will copy the a coefficient as well, and we can gather the x's, so we can see how does it become a quadratic equation. So x squared minus x, we will put it this way, times alpha plus beta plus alpha plus beta. And when we see that, we can unveil the a now. So when we copy the third row, we actually get this row here, which is pretty interesting because we can compare the coefficients. And now we have, of course, a times x squared, which is the first one. We get the second one, which is b times x, and minus a times alpha plus beta. And we get the third one actually, which is c, and which is a times alpha times beta. When we write that down, we don't really have to write it for a because it is the same, but we can say that b is equal to minus a times alpha plus beta. I won't write the x, but what we get from here, I will change the right and the left side of the equation. Alpha plus beta, which is the sum of our roots, is equal to minus b over a, which is the exact formula we had to write down. And when we get the green line, we see that c is equal to a times alpha times beta, and alpha times beta, which is the product of our roots, is equal to c over a, which is good because we got that formula as well. That was from the proof part of our video, and now we can write an example to see how does this work. So if we have to write a quadratic equation, I will give it with pretty much random numbers, like 5 times x to the power of 2 plus 2x minus 3 is equal to 0. And what we will do now is say the coefficients and what they are, because it is important. A, which is the first coefficient, is 5. That is good. B is 2, and C is minus 3. We get it with the sign in front of the number. Like the 3 we get the minus, with the 2 we get the plus, and when it is the first coefficient we get, if it doesn't have minus in front, we assume it is plus. So the sum, if we want to find it the old-fashioned way, we will use discriminant and see where this will go, but it is going to be a slow process. However, you can use these formulas, and alpha plus beta is equal to, as we know from the formula, minus b over a, which is minus 2 over 5, which is 2/5, minus 2/5, and this is the answer if we want for the sum. And if we want to find the product of those numbers, we will simply write c over a, which is minus 3 over 5, which is minus 3/5, and this is the product of our roots. And that was from this video. Thanks for watching. I hope you liked the video. If you want to support me, you can subscribe to the channel and like this video. You can leave a comment how I can improve myself. That's my first video in this channel, and I will be back soon with new proofs, examples and questions that we're going to discuss in the future. Thanks for watching.